For this assignment, we're going to start something new, finding a missing angle. We've talked about how to find a missing side using sine, cosine, and tangent. This is a little bit new. For problems 1, 2, 3, 4, 5, 6, 7, and 8, if you need help with those, watch the videos on the previous two assignments. For problem number 9, we're finding an angle. When we find an angle, we're still going to set it up with sine, cosine, or tangent, but we're going to mix it up a little bit. Instead of regular sine of an angle equals sine of an angle is equal to the opposite over the hypotenuse, now the sine inverse of opposite over hypotenuse is equal to the angle. We use an inverse sine or an inverse cosine or an inverse tangent to find the angle. You'll find sine inverse if you use Desmos. Let's see, Desmos. Make sure that you're set in degrees. You'll find the inverse sine, cosine, and tangent if you hit function. Here on the bottom right corner, I see the word functions. And it's the little sine, cosine, tangent with the little -1 on it. Those are the ones we're going to use. So sine inverse would look like that. Okay, so let's see. This, I better write these out. So, katoa. Sine inverse of the opposite over hypotenuse is equal to theta, our angle. Cosine inverse of adjacent over hypotenuse is equal to our angle. Or tangent inverse of opposite over adjacent is equal to the angle. So they all equal the same thing, the angle. You just have to choose the appropriate one based off the two sides they give us. So in problem number 9, they give us opposite and adjacent. So we're going to choose tangent. The tangent inverse of 4 over 5.1. 4 over 5.1. Let's see, 4 over 5.1. Inverse tangent, 4 over 5.1. So about 38.1. So this would be about, theta is about 38.1 degrees. Make sure you do both the odds and the evens. Don't just fill in the ones that I'm doing on this video. Do all the problems. For number 11, well, that's the same. So let's find one that's not tangent. Okay, number 10. Number 10 is not tangent. Let's see, this is the adjacent, and this is the hypotenuse. Adjacent hypotenuse uses cosine. So the cosine inverse, we always use inverse when we're looking for an angle, of 11, the adjacent, over 12, the hypotenuse. Cosine inverse, 11 over 12. Cosine inverse, 11 over 12. So if we go to the nearest tenth, we'll say 23.6. Theta is about 23.6 degrees if we round to the nearest tenth. Okay, let's find one that's sine. Okay, number 14 is sine. This is opposite of the angle. And here's hypotenuse. So we have sine because it's opposite hypotenuse. The sine inverse of 5 over 15, opposite over hypotenuse, will equal the angle. Sine inverse of 5 over 15, so about 19.5. The 7 tells the 4 to go up, so that's about 19.5. So the angle is about 19.5. Choose the appropriate sine, cosine, or tangent based off the two sides they give you. If they give us opposite adjacent, use tangent. If they give you adjacent hypotenuse, use cosine. If on 14, like the 14 they give us opposite hypotenuse, use sine. Based on the two sides they give us, choose the appropriate sine inverse, cosine inverse, or tangent inverse to find the angle. If you need help with the previous problems 1 through 8, look at the videos I put on the previous 2 assignments.